These are the notes for AP Calculus on the topics of direct and inverse proportionality, or sometimes it's referred to as direct and inverse variation. So if two variables, y and x, or we can really use whatever letters you want here, are directly proportional, or sometimes it's just referred to as proportional. It's the same as directly proportional, or sometimes it says varies directly. If there is a non-zero constant k, so k is just some constant that's not zero, otherwise zero would wipe out the x there, you can see, such that y equals kx. So in terms of magnitude, how large it is, you can see as x gets larger, so does y. When they're directly proportional or proportional varies directly. However, if two variables y and x are inversely proportional, this also may be worded as it varies inversely. If there is a non-zero constant k, such that y equals k over x. And notice here, as normally we're dealing with positive numbers in these cases here. So as x gets larger in magnitude, that makes the denominator larger, which makes y smaller. So inversely proportional, as one gets larger, the other gets smaller. Directly proportional, as one gets larger, the other gets larger. That's the basic concept there. And k, this constant here, has a special name. It's called the constant of proportionality, or sometimes the constant of variation. So the general steps for solving these proportionality problems I put down here, you're going to first usually try to write an equation using k as the constant of proportionality that accurately describes the type of variation. Then you're going to step 2, using the given information, solve for the constant of proportionality k. Then step 3, substitute the constant of proportionality k into the original equation from part A to represent the exact relationship between the given variables. And then use the equation from part C to answer the question at the end of the problem. So they don't all follow this exact pattern, but a lot of them follow this. Okay, so it says, suppose the rate R that water flows out of a dam is proportional, that means the same as directly proportional, to the annual amount of snowfall, I'm using capital A, in the mountains above the dam. So let's try to write that out first. So R is directly proportional. Proportional is directly proportional, so it's just K times the amount of snowfall, annual amount of snowfall, which is A. Then it says water flows out of the dam at a rate of 10 billion gallons per day when there are 40 inches of snowfall in a year in the mountains above the dam. So let's put that information in. So we know R is 10 billion gallons per day. So you can either write 10 billion here, or you can just write 10 and remember it's in billions of gallons per day as the units. And we don't know the proportionality constant, but we know when R is 10 billion, that's when there are 40 inches of snowfall in the year in the mountains. And that's what A represents. A is 40. So then you can use this, once you have one data point here, you can use it to solve for the proportionality constant. So if you divide by 40, you get K equals 10 divided by 40 reduces to 1/4. And then what you do is you substitute the 1/4 back in here for K, back in the original equation. So now we have the exact relationship. R equals 1/4 A. And now we can answer the question at the very end. It says, at what rate will the water flow out of the dam? So we're looking for R. When there are 60 inches of snowfall in a year in the mountains above the dam. So R would equal 1/4, and A is 60. So R would equal 4 goes to 60 15 times. But here's where it's important to remember the units. Remember, the units for R were not gallons per day, they were billion of gallons per day. So it'd be 15 billion gallons per day. All right, so we start with a pretty basic example here. Now let's take a look at another one here. This one says the distance y, so y is one of our variables, then an object falls is directly proportional to the square of the time t. So notice it's not to the time, it's to the square of the time. Okay, so let's write that down first as our basic equation. So the distance y that an object falls is directly proportional, so it's k times, not t, but the square of the time t, so t squared. A certain object falls 64 feet in 2 seconds. Okay, so y is 64. That's our distance that an object falls, and time is 2. For t, and solve this for a proportionality constant k. So 64 equals 4k. Divide by 4. We get k. 64 divided by 4 equals 16. So now I can substitute 16 back in here for a proportionality constant. So get our equation, y equals 16 t squared. And now we can answer the question at the end, how far will this object fall in 5 seconds? So y equals 16 when time is 5, so 5 squared. We have 16. First you do exponents before multiplication, so 5 squared is 25. 16 times 25, just think about money here. You've got 4 quarters of a dollar. So 4 times 25 would be 100, so 16 would be 400. And you look back at the problem for the units. The units here are feet, so 400 feet. All right, let's take a look at the next one here. So this is Boyle's law states that the pressure P of a gas is inversely proportional this time to the volume V of the gas if the temperature remains constant. At a certain temperature, when the gas is in a 4-liter container, so let's first write down that equation first. So the pressure P is inversely proportional, so it'd be K over the volume. And it says at a certain temperature, when the gas is in a 4-liter container, so the volume is 4. We don't know the proportionality constant. The pressure of the gas is 12 pounds per square inch, which we abbreviate as PSI. So this one, to solve for K, you would just multiply both sides by 4. Reducing the 4 there, so that would give you K is equal to 4 times 12, 48. We can substitute that back in here. We get our equation for the pressure of the gas is 48 divided by the volume of the gas. And then it says, at the same temperature, what will the pressure of the gas be if it is transferred to a 1/3 liter container? So P would equal 48 divided by 1/3. So that'd be 48 divided by 1/3 is the same as multiplying by the reciprocal, 3/1. And 48 times 3. Well, 3 times 40 is 120. 3 times 8 is 24. 120 plus 24 is 144. And the units for pressure in this case are pounds per square inch, which you could abbreviate as PSI. Let's take a look at the next example here. It says, suppose a tennis player has a return of serve percentage P that's inversely proportional to the square of the speed of the serve S. So let's write our first equation here. So P, return of serve percentage, is inversely proportional, so K over the square of the speed of the serve, so which is S. So S squared. When the speed of the serve is 90 miles per hour, the tennis player's return of serve percentage is 70%. So P is the return of serve percentage, so that's 70%. speed is 90 miles per hour, so 90 squared. So 90 squared, see 8100. And then to solve for k, just multiply by 8100 sides. So we get k, proportionality constant is, well, let's see, 81 times 7, 80 times 7 is 560. 1 times 7 is 7. So 567, and then add the 3 zeros. So 567,000 is our proportionality constant here. So P would equal $167,000 divided by S squared. And now we can answer the question. It says, what will be the tennis player's return of serve percentage for serves that have a speed of 100 miles per hour? So P would equal 567,000 divided by 100 squared. Simplify that. Let's simplify the squared first. 100 squared. 4 zeros would be 10,000. So you can use your calculator if you want to, but it's not really necessary here. You can see the zeros divided by 5,000. We knocked off all the zeros. And we've got 567 divided by 10. Well, divided by 10 just moves the decimal point one place. So the return of serve percentage would be 56.7%. Next example says, suppose the cost C to manufacture a television is directly proportional to the square root of the size of the screen L. And L is measured by the length of the diagonal, one corner to the opposite corner. All right, so C would equal, it's directly proportional, so it's K times the square root of the size of the screen. So the square root of L. Then it tells us it costs $120, so that's our cost, to manufacture a television with a 25-inch screen. Square root of 25 is 5, so we get 5K. 5. K equals, well, 10 goes into 120 12 times, so 5 would go into twice as many times, 24. Substitute that right back in here to get our general equation here. The cost would equal 24 times the square root of L. And then it asks, how much does it cost to manufacture a television with a 36-inch screen? Oops, the square root of the wrong place here. So 24 times the square root of 36. Square root of 36 is 6. 6 times 20 is 120. 6 times 4 is 24. 120 and 24 gives you 144. And the units for cost here are dollars. So $144. The next one says the rate R at which a virus spreads among a population of X people, X is the number of people, is proportional, so it's a little more complicated, to the product of the number of people who have contracted the virus and the number of people who have not contracted the virus. And V denotes the number of people who have contracted the virus. Write an equation using K as the constant that can be used to model the situation. So we're just setting up the model for this, okay. So before we do this, let's kind of define it. We're going to need to know the number of people who have contracted the virus and the number of people who have not contracted the virus. So remember, X is the total number of people. X people. Total number of people. And then, you guys know that means number, right? Not just hashtag, okay. That's total number of people. And then we've also got V, to tell us, is the number of people who have contracted the virus. Number of people who have contracted the virus. So if we want, we need some expression for the number of people who have not contracted the virus. Well, wouldn't that just be the total number of people minus the number of people who have contracted the virus? Is the number of people who have not contracted the virus. Yep. So it says write an equation using K as a constant to be used to model the situation. So the rate R is proportional, so K. What it's proportional to is the product, means we're multiplying. And what the product is, the number of people who have contracted the virus, that's V, times the number of people who have not contracted the virus, we just figured out, is X minus V. And that's all you have to do, set up an equation with model it. We're not giving any other data here, so that's all we're asked to do. Let's take a look at the next one here. It says the surface area S of a sphere is related to the radius R of the sphere by the formula S equals 4 pi R squared. Okay, that's the surface area formula for a sphere, where R is the radius and S is the surface area. And then for part A, it says describe in words the relationship between the surface area and the radius of the sphere. So take a look here. Are they directly proportional, inversely proportional? You can see there's no fraction there, it's multiplied by 4 pi. So the way you could say this is the surface area of a sphere is directly proportional, or you can just say proportional, or it's the same thing, to, but it's not to the radius, notice it's R squared, to the square of the radius of the sphere, which is what R stands for, the radius of the sphere. All right, then part B, what is the constant of proportionality? What is that K value? Well, you can just look at the equation here and see, all right, that's where K would go, right? If you were to write this, so K, our constant of proportionality, is just 4 pi. And then part C says, if the radius of the sphere is tripled, what will happen to the surface area of the sphere? So let's take a look at our equation. We've got S equals 4 pi R squared. Well, tripled means multiplied by 3. The radius is tripled. So we don't have specific numbers here, but we don't need it. So if we, instead of R, we put in 3R. Let's simplify that. The radius is tripled. It's 4 pi of the times 9R squared, which would give you S equals 36 pi R squared. So we started out with 4 pi R squared, right? Well, when the radius is tripled, it became 36 pi R squared. So what happened? There you go. The surface area of the sphere is multiplied by 9. And that concludes the notes for AP Calculus on the topics of direct and inverse proportionality.